All right. This is our second one for the day. So lecture day 10, part B. This is 10.2, completing the square. And although I'm not going to start with it, we want to come back and show how we got x squared minus 8x plus 41 to equal x minus 4 squared plus 25. Because this was the equation we had to solve earlier, and when we worked backwards, we got that. And I want to show you how these two are connected. But let's start with something easier. And let's start with a simple rule. If we have, like, we'll ignore, there's not going to be any a. We're just going to have an x squared plus bx equals 0. To complete the square, add 1/2 of b squared to both sides. And the side with the x's will turn into x plus 1/2 b squared. That's something I could have mentioned earlier in the math 335 class. I didn't write down a rule for it, but equals like the 1/2 b squared. Nope, that's 1/4 b squared by squared. So let's look at an example. W squared plus 4w equals 0. Now we already know how to do this with factoring. This is w times w plus 4. And if you factor, you're going to get w equals 0 or w equals -4. But we're not going to do that. We're going to do complete the square. So I'm going to give myself a little room. I should have done it on the last line. What I'm going to do is I'm going to take this 4. And it's a positive 4. I'm going to bring down the sign with it. I'm going to divide it by 2 and I'm going to square it. That's what goes in parentheses right here. 4 divided by 2, positive 4 divided by 2 is plus 2. That's going to end up being that. Four divided by 2 is 2, and 2 squared is 4. So to follow rule A, I'm going to add 4 to both sides. And I follow this down, 0 plus 4 is 4. I'm going to diverge for a second. If we had just done it like this, you can do factoring shit where you see that this is w plus 2 and w plus 2. Like you can do your normal factoring stuff and you can see that this factors like that. But if we follow the shorthand, this is that. And if you just memorize that, this gets a whole lot easier. So now I've got w plus 2 squared equals 4. And we can extract roots. Square root of 4 is 2. So if I subtract 2 from both sides, I get w equals -2 plus or minus 2. You definitely don't want to leave it like that. I will totally mark you down points if you do. This is -2 plus 2, or w equals -2 minus 2, and that's 0. And that's -4, which is what we got up here. For fun? So, was there, like, it's a little complicated to remember, right? But did we do any, like, actual complicated math steps? We divided by 2, we squared it, and we added. That's literally all we did. Basic arithmetic operations, just remembering to do them is the part that you have to remember. So you take 1/2 of whatever's in front of the variable with no exponent, cut that in half, and square it. I think we had, earlier, we had x squared minus 13x minus 30. I know we did. We factored this. We saw that we had x minus 15, x plus 2, and we got x equals 15 or -2. But we can do this with completing the square, and we're going to, because it's good practice. Handy thing to do is add 30 to the other side right away. And I'm gonna leave a little room to add that stuff that I'm gonna do. We take this, it's -13, we divide it by 2, and we square it. Which is 169/4. That's what's getting added to both sides. We can shorthand the left side to doing x minus 13/2 squared. The right side without a calculator, I'm going to get a common denominator. So 30 times 4/4 is 120/4. And I'm still adding 169/4. I got 289/4. Then we'll take the square root of both sides. I think 289 is 17 squared. Does anyone have a calculator where they can check square root of 289? I think it's 17. Because this is, we can do the square root separately. That's like that. So I know the bottom's 2.
Yeah, that's 17.
It's 17. And we have a plus or minus. So this is, if I add 13/2 to both sides, I get x equals positive 13/2 plus or minus 17/2. Which is 13 plus 17/2 or 13 minus 17/2. This is 30/2, which is 15. This is -4/2, which is -2. Which you can see is what we got up there with that. Now, granted, factoring was a lot easier here, wasn't it? So obviously, when you're going to solve a problem, you want to go with the method that's the most efficient, the easiest to do. Factoring, as we've already shown, isn't always fucking easy. Completing the square or extracting roots always works. It'll deal with radical numbers, it deals with imaginary numbers. Extracting roots always works, but sometimes getting it into that form is the pain in the ass. So this completing the square is what does it.
So it's like this is fair flat. This is like.
Yeah, this is.
The other way we're kind of guessing a little bit, but This is like hard numbers. We can-
This is hard numbers and it's gonna work every time. Now, I wanted to avoid using a calculator, and so, cause I just didn't wanna pull out my fucking phone and set the calculator mode up. If you were doing a calculator, you'd probably have like 6.5 here. And you might have had this as a decimal, but when you took the square root, you were gonna get 17/2, which is 8.5. And you would have still ended up with 15 or -2. Whether you worked with the radicals or the decimals. So that's what happens when we have something added there. Just move it first. What happens when we have ax squared plus bx plus c equals 0 and a does not equal 1? Actually, before we do that, let's go back to the one we started this fucking topic on. X squared minus 8x plus 41. Do complete the square on this. Go ahead and give it a gander.
Do you leave the 41 there after you do the 8 divided by 2, or does that get sucked in?
You can either leave it there, but it will,
Side.
or move it to the other side. I think moving to the other side is the easier route to go. How we doing, guys? I wonder if they're gonna make the 4 years change. I don't think the law applies to them yet. But if the fucking legislators have any thing to do with about it. I'm sure they will, because Fresno State has a college algebra with support.
Anything to keep the big money making schools open. That's.
Alright. So what do we do here? Get rid of the 41. I like that. Let's do that. Excellent choice, Teresa. What else should we do?
Thing.
We're gonna do that thing?
Yeah,
What's that thing involved?
the 1/2 b squared t.
So we're gonna do -8/2?
Yeah.
And we'll square it. That's -4 squared, which is 16. So we can add 16 to both sides.
And then, cause that's like, now it's like a perfect square or whatever, right? Whatever
That's the right terminology.
thing,
It's a perfect square.
and then equals -25. And then square root,
And we did all this before.
yeah. And then we get all sorts of fun imaginary stuff.
Now, the imaginary stuff may seem pointless, and we, in your major, it may be pointless. But like, everything that we enjoy in the modern world is based on pretty much the electricity. Electricity is almost in everything we use. It's even taken over reading now. Where it used to be a printed book, now it's a Kindle, shit like that. And all of the stuff in electricity is based on complex numbers. It's based on sinusoidal waves, sine and cosine, which we'll learn in trigonometry, PrecCalc B. And in some cases, there's an imaginary component. That gives you the alternating current part, AC. All right, so. Do that one, use that one in a second. Okay, so we're doing ax squared plus bx plus c equals 0, and a does not equal 1. We modify our approach a little bit. Step one is divide by A. Step two now goes back to the add 1/2 B squared. And complete the square. So. X squared minus 4x plus 8 equals 0. Wait, that doesn't,
I was like,
that's
hey,
not an A equals 1. Next page. And it's 0. Alright. Divide by A. Divide by 4. Divide everything by 4. If you've already moved the 9, that's fine, but everything gets divided by 4, even the 0. Doesn't do anything to the 0, but it's worth showing. Because people forget to do shit to both sides. And I'm gonna move that 9/4 to the other side. By adding it. So here, I want to take -7 divided by 2 and square it. That's 49/4. The left side is just x minus 7/2 squared. Over here, I have 58/4. That reduces, but I'm not gonna reduce it. Because when I take the square root, if I reduce it, I'm gonna end up with a 2 on bottom. If I take the square root, now I've got a radical on bottom. That's messy. So we're just gonna leave it like that. Hit that bad boy with the square root. That is plus or minus square root of 58 over the square root of 4. And since we didn't reduce, we have a nice simple bottom right now. So the exact answer, adding 7/2 to both sides, x equals 7/2 plus or minus square root of 58 over 2. So that's an exact answer. You'll also see it in the form 7 plus or minus square root of 58 over 2 that way. Put them all as 1. And remember that means x equals 7 plus or minus square root over, not plus or minus, let's just do plus square root of 58 over 2, or x equals 7 minus square root of 58 over 2. So if you need actual like decimal numbers. Square root of 49 is 7. Square root of 64 is 8. And this 58 is closer to 8 than 7. I'm gonna guess it's approximately 7.6. Anyone got a calculator? Tell me if I'm right. Maybe 7.7 to be round,
For what?
58.
7.615.
7.6, okay, we'll leave it at 7.6. But there was more decimal places. So that's 14.6 over 2. Which is 7.3. Or we would have had 7 minus 7.6. Would have gotten around negative 0.3. You did the decimal. This is an approximate answer. So exact leaves the radicals and fractions in. Well, the radicals.
That's if you were to ask, like, put it in decimal form.
If it asks for an approximation, decimal form, something like that. If you're using it like to graph or something. The exact is not fucking helpful, but the approximate is. Like we
Never
could,
ask us to put it in decimal form in the contest.
I won't.
It might come later, or
You use decimal form later. Like when we're graphing, if you have like a root, this ends up being something called a root. I can't graph 7 plus square root of 58 over 2. Comma 0. I don't know where that is on the graph. But I can find 7.3 comma 0. So like when you're graphing the shit. All right, ready for another fun one? I guess I could have said 2x squared plus 3x minus 2. But I didn't. So little things to do. If I move the 1 over, I've got that. Most people are usually just putting divided by 2, but remember, this is 1/2 times b, or 1/2 times 3 over 2. And that is 3/4. So 3/4 squared is 9/16. On the right side, I've got, well, if I get a common denominator, I've got 16 over 16 plus 9 over 16, that's my 1. And that adds up to 25 over 16. So we'll hit it with our roots. That is gonna be 5 over 4. So subtract 3/4. And get x equals negative 3/4 plus or minus 5/4. This one simplifies to 1/2. And this simplifies to -2. Okay, the next 4, I'm gonna like set up, show like things that you should be aware of, but we're not gonna walk through in the interest of saving some time. Because the process after that doesn't change, but there are little things like you should be like, hey, wait a second, don't do this or do this. Like you may have something like 3x plus 1 in parentheses times 2x minus 4 equals 7. And at some point you're going, what is the easiest route to go? You can't do the a times b equals 0 because you don't have a 0. So no 3x plus 1 equals 7 or 2x minus 4 equals 7. Can't do that. Only works if the right side is 0. So the way to go about it is subtract the 7 and multiply this shit out. Multiply it out. If it factors, save yourself some time. Otherwise, you'll do complete the square or what we're gonna do on Thursday. Another one to be aware of is if like the a is negative. Make that a 2, negative 2x squared. When we get it down to like x squared plus bx plus c, this is positive. So you want x squared to be positive. So one way would be to multiply through by a negative number. Or when you divide, just make sure you divide by the negative as well. X over 2 is 1/2 x. And I would probably rearrange the order here. Now complete the square. Ready for the next one to things that don't do? There's a lot of bunch of people writing, let me be patient. Alright, next don't do thing. If we had something like x times 3x minus 5 equals x squared. Don't divide by x, you may be inclined to. If you did. You get 3x minus 5 equals x. You would solve, you get 2x minus 5 equals 0. You would get x equals 5/2. Which I'm sure is still one of the answers. But. There's a missing answer. If you work this out, you're also going to see x equals 0 works. In fact, you can see it right here, plug in 0. 0 times anything gives me 0 on the left side. 0 squared on the right is 0. 0 equals 0 is a true statement. So x equals 0 is a solution, but if you divide it by x, you wouldn't have gotten it. So while it might be like, oh, that makes shit easier. Yeah, it does, but you also miss answers. So instead, multiply it out, collect the terms. So instead, you do something like 3x squared minus 5x. And then subtract the x squared over, bring it over. And you got 2x squared minus 5x equals 0. Then you could factor and do your x equals 0 will pop out there. In fact, dividing by x means we divided by 0. That's a hell no. That's bad juju right there. Sometimes thinking is easier than just plugging and chugging. I could multiply this out. I got x squared plus 5x minus 10x minus 50. And then I got x squared minus 5x minus 50 equals 0. And it's factorable and I can do shit there, but like you're already in like a semi-completed factoring, or factor out x plus 5. And right away, if I take out the x plus 5, I'm left with x minus 10. And you'll see you would have gotten there, but you didn't have to do all the multiplying out and stuff like that. So there's nothing wrong with doing it, and there's no wrong thing to do there, but you can save yourself some time. And now we're going to do complete the square on the generic equation. We are going to start with ax squared plus bx plus c equals 0. What are my steps here? Even if I had numbers here, I'd use numbers, but I don't. What were my steps here? Divide by a, right? So I get x squared plus b over a x plus c over a equals 0. Then we probably would move that c over a over, right? We'd subtract it over.
One half b squared.
So we're going to take this and we're going to multiply by 1/2. And we're going to square it. That is b over 2a squared which is b squared over 4a squared. The left side just comes down as to, if I do this, I have b over 2a squared. The right side, I don't have a common denominator yet. What do I need to multiply this by so that I get a 4a squared on bottom? What do I gotta multiply it by so I get a common denominator? It's already got one of the a's, what is it missing? It's missing a 4a, right? So this would be negative 4ac plus b squared over 4a squared. And I'm gonna turn that around real quick. Because the squared term is nicer up front. Now what? Do the square root, right? I got x plus b over 2a equals plus or minus the square root of b squared minus 4ac. 4a squared, the square root of 4a squared is 2a. In fact, we saw that here. We started off with 2a squared on bottom. So that's just 2a down there. So if I get x by itself, I subtract the negative b over 2a. And since everything's over 2a, I can make it one big fraction. And we now have a general formula for x. For a quadratic equation. This right here. Quadratic formula. And I believe that's 10.3, and we're going to do that on Thursday. But using it. If you memorize it, you can jump straight to it every time and it will always work.
Really?
Yeah, because it's the same thing as completing the square. And we saw that extracting roots and completing the square always works. But this is just one formula. It doesn't matter what ax squared plus bx plus c is. Doesn't matter what these fucking are. You plug them in, it's gonna work.
That's only if they're not like variables, so right? Like you don't know exactly what they're. Or it's never like that.
If I had like any formula or any equation with no a, b, or c, just other numbers in, I'm just replacing a, b, and c with what those numbers are. We'll see it on 10.3. And there's even a nice little fucking jingle story that goes with memorizing it. If it makes it easier to help you memorize. But that's 10.3, that's another day, another dollar. That's it for this section. You are free to go. You can get the fuck out if you'd like. Or you don't have to. We got a couple more minutes if you want to ask questions. Reminder, I'll be on Zoom tonight at 8:15 if you need help.